All right, the next group of problems in 6.1 has a little bit different instructions. So the instructions here say in the following exercises, find the radius of convergence R and the interval of convergence for sum of an x to the n with the given coefficients an. Okay, so here we go. Let's do number 13. I'm going to do the same sort of basic principles that we did before. So let's use the ratio test. You can use the root test as well, but let's use the ratio test. I like that one. All right, so that means we take the limit as n goes to infinity of, well, what do we have here? Let's make a big one here. We got 2x quantity to the n plus 1 over n plus 1. And all of this is going to be over to quantity 2x to the n over n. And that's limit as n approaches infinity. Again, we multiply by the reciprocal here. So that's going to be 2x to the n plus 1 over n plus 1 times n over that 2x to the n. That's limit as n approaches infinity. And what do we have here? We're left with 2x up top, and then we have n over n plus 1. Guess I don't need this. So times n over n plus 1. Okay, so what do we have with the n over n plus 1? Well, as n gets really, really big, this whole thing is going to go to 1. So for our convergence, we need absolute value of 2x, or 2 times the absolute value of x will work. So we have, so it converges for the absolute value of 2x being strictly less than 1. And again, we can pull the 2 out and divide, so that means x is going to be less than 1/2. So that means our radius of convergence r is equal to 1/2. The second part of the problem, however, it wants is an interval of convergence. Let's see. Can I move this? I guess not. All right, so let's work on this one here, and then we'll do number 20 as best we can. Let me give it some space here. Okay, so we're going to test x equals 1/2, right? See what happens. So let's scroll up a little bit. That means that we have the sum n equals 1 to infinity. We put in 1/2 for 2x, so it's going to be 2 times 1/2 to the n over n. So that equals the sum of 1 over n. Well, what happens with that? Well, in that sort of situation, that does look like it is going to be a geometric or a p-series, excuse me. So this is p-series. And we know that in this case, our p is equal to 1, so that means it diverges. So 1/2 is not going to be part of our interval of convergence. Well, let's test x equals negative 1/2. We put in negative 1/2. Then what we get is negative 1. Instead of 1 to the n, we get negative 1 to the n over n. And this is an alternating series, and this converges as the alternating series converges. All right, because we take the limit as n approaches infinity of 1 over n, that equals 0. This is why. Give that reason as well. And therefore, the interval of convergence is, well, it includes negative 1/2, so we'll use the bracket there, and it goes to positive 1/2, but doesn't include it, so we'll use the parentheses. So this is one where we had to test both types there, both the endpoints for R. All right, let's take a look at number 20. I'll do that in a different script here. Let's try green. There we go. Okay, so let's bring number 20 down. Let's use the ratio test again. So by the ratio test, we take the limit as n approaches infinity, and it's going to be this whole thing to the n plus 1, so x n plus 1 over n plus 1 quantity factorial divided by x to the n over n factorial. And again, we multiply by the reciprocal. And so it's times n factorial over x to the n. Now, what we have here we're left with an x on top, but on the bottom, so n factorial is going to be, let's do an aside here. N factorial is n times n minus 1 times n minus 2 and so forth. N plus 1 factorial is n plus 1 times n times, or n plus 1 times n factorial is probably just easier to do. All right, so then we can basically cancel the n factorials and we're left with just n plus 1. All right, does that make sense there, I hope? All right. So what does this limit equal as n gets infinitely large? Well, this just equals 0. We don't worry about the x. N is the only thing changing here. So as n gets bigger, bigger, and bigger, bigger, we're getting a larger value in the denominator, which means this equals 0. Therefore, R equals infinity. Or essentially, basically for every x in the real numbers, it's going to work. So our radius of infinity is that, and our interval. So this is our radius. Our interval is going to be negative infinity to infinity as an interval.